demo of undo recording technology, showing how we can integrate Java and C++ and step across from Java into C++ in the same recording. So we've got our Java docs up here and C++ docs here. So what I've chosen to demonstrate is Apache gluten Velux. Velux is a part of Apache Spark that's written in C++, which is provides good performance for Apache Spark. You can see how it fits in here, and I've created a recording basically by running this script. We've got our tool options here, which include our agent, which outputs recording in gluten.undo. This is just running a Spark shell, and it's running one of the supplied workloads, and so that creates a recording which I've loaded into IntelliJ. And when I look through the output from it, I noticed that there's an error being output, a runtime exception. And so what we need to do is work out how we can figure out where this exception came from, because this exception actually had its roots in the on the Velux side, on the C++ side. So this is an exception that was thrown in Java, but it was produced by the JNI code. So what we can do is, so we've got our output here. So this is all the output from, we've just run to the end of the recording. So this is all the output from the run. And this is the error that was output. And as you can see, it's saying message 2D max recursion depth reached. So we might want to figure out how that happened, what's going on. So what we can do is we can copy the timestamp, and we've got a log jump thing here which lets us jump to various things, but for this instance we'll just enter a timestamp. And so that's jumped to that timestamp, which is not exact. So we need to find out exactly where that exception was thrown. So what we're going to do is, so this is roughly where it was thrown. So we're going to set a breakpoint on runtime exception, and then we're going to go forwards to find out exactly where it was thrown. Okay, so this is where it's being thrown in the JNI let. So we can see that the native JNI call has thrown an exception. So now we need to figure out the actual BB count. BB counts are a kind of internal counter that undo uses. It's a count of basic blocks. So basically we can get the BB count for where it's just about to go into the JNI code, and then we can go over to the C++ side and we can use that same BB count to figure out, to step through the C++ side. So so this is the point where it's actually thrown the exception. So what we need to do is we need to go up a bit to before where it did the call. So now we're going to go backwards in time. So now we've gone back before the JNI call was made. So if we make a note of the BB count just here, we'll just copy that. So that's the JNI side, that's the Java side. So we're now going to switch over to look at things on the C++ side. So let's open up the same recording. So I'm going to open up the same recording. We're using 2E mode of UDB. Just wait for the recording to load, and then we're going to jump to the time that we just copied. And we're going to set a breakpoint at, this is something I saved earlier. So this is the, so we're going to set a breakpoint at the JNI routine. And then we're going to run forward to it. And then we're going to step through a C++ code. I'll just set a bookmark just here. You'll see why in a sec. I'll step into that. Okay, this is C++ stuff which we're not interested in. So we'll say skip that. We'll go back to that bookmark. I'll step in again. And now I'll step into this. Again, we want to do a similar thing. Okay, so here we are in, this is where we're getting down into the Google Protocol buffer stuff. So this is, it's actually a bug in the Google Protocol buffers code. Well, it's actually a feature, not a bug, but we'll see, as you see in a sec. So we can step over that, and if we look at the status, we can see error message. This the message that we saw in IntelliJ. Same message, maximum recursion depth. So we've got to the point where that was produced. So now we can, what we can do is, if we want to go backwards and find out exactly where that happened, then we can use the last command, UDB last command. That's where that status was set, and this is copying it from another status thing. So what we want to do is we want to set a breakpoint at line 93. And then reverse continue. And this is basically where that error message was first set. So if we go up and up again, then we can see where it went wrong. It went wrong in a thing called increment recursion depth. It found that the recursion depth was greater than max recursion depth, and that's where it's actually thrown the error. And you can see that was called from here. So yeah, that's it basically. The actual bug itself is, like I say, it's due to the fact that the JSON that's been passed in has caused too much recursion. This max recursion depth is unfortunately hard coded. We can see where that was set as well. And that's set to this thing called K default max recursion depth, which is a hard coded limit. And actually, there's a known bug which is reported by somebody else just here. They had the same thing. They opened up a defect to allow a user to specify a maximum recursion depth, but yeah, so that's the demo basically. Just wanted to show how you can interleave between UDB and IntelliJ.